So I was told that the audience for this might be different than the audience for the previous presentation. So I do have some of the same material. And I'll go through it quickly here. But certainly if you are seeing this without the benefit of seeing the first one, and you have questions, you can contact us and we will answer your questions. So I hope the whole thing here is to be helpful to you. Here again, we have the Neams program. My name is Dan Funk. I'm the program manager for the Nuclear Energy Advanced Modeling and Simulation program. And just going to give you a quick program overview, just a few slides, and then focus primarily on the fuels product line, lower length scale, mesoscale efforts under Marmot. And the purpose for that is, the reason for that is that the scope is directed towards that need, meeting that need. So here again, our value is to develop and deploy advanced computational tools to R&D programs. By deploy, we don't mean simply to provide a tool for somebody's toolkit to use periodically, but to provide it and help integrate it in the way that becomes part of the DNA of that R&D, and that it helps transform that R&D in ways that are significant in terms of accelerating the R&D and increasing the scientific discovery and improving the concept development that is purposed by that R&D. We have several mission areas. These are outlined here. It's not a comprehensive list of our codes, but helps you depict the focus in our areas where we have 3 product lines: fuels product line, the reactors product line, integration product line. And you can see the names of the gentlemen that lead those. And off to the right on those lines, you can see some of the main areas of focus. For instance, Bison, the fuels performance code under the fuels product line, the Sharp suite with a number of reactor related codes under the reactor product line, and then the integration product line with the Neams workbench and activities related to the deployment of tools, the visualization capabilities in those tools, and also the under that product line, we've got another work area that you can see at the bottom of the slide, modeling simulation to support treat operations and use. Also, you'll see that connected to the integration product line are investments, and there you see them listed. And the one of relevance here primarily are our investment in university programs, which is important and substantial. We also have efforts ongoing in high impact problems. Those are problems that we engage with customers, and we attempt to use our tools to solve these problems that are of importance to them, of high impact to them. And this is an area that's growing and will consume a larger percentage of our resources in the coming years. Here's the Neams organizational structure, so you can see the usual suspects. This is the Leadership Council. These are the folks that provide the technical and programmatic leadership to execute Neams and to make it reach its goals and provide the products that are needed, as you can see there. This gives you a face to go with the name, and hopefully when you reach out, if you do need to reach out to us, you can reach out to Brad Reardon or Steve Hayes or Chris Stanek in this area. Those would be the 3 that Brad is our primary point of contact, our technical point of contact for NIA. So he would be the best first contact. So in the fuels product line, you can see that what we're trying to do is we're trying to crack the nut of understanding the microstructural changes in fuel and cladding during reactor operation. This is approached at a number of scales. You can see here the atomistic simulations in nanometers to the hundreds of nanometers in molecular dynamics, leading into the mesoscale, micron scale with Marmot, and then implementing those mechanistic physics models into Bison, the engineering scale fuel performance tool. And those both operate in the Moose framework at INL. So this is another depiction showing how Marmot and Bison work on Moose, and showing some of the traits and the capabilities at each scale. So Marmot, the focus of this subscope, it predicts coevolution of microstructure and physical properties in fuel and cladding materials due to applied load, temperature, and radiation damage. So the things that are important here is that all the models implemented in Marmot are 1D, 2D, or 3D, massively parallel from either 1 to thousands of processors, and able to employ mesh and time step adaptivity. The physical models are listed. Those include the ones you see on the slide, so you can see what they're working on right now and what they have now. And there's a little graphic there to show some of our users and stakeholders for Marmot. So as I said before, the nature of this subscope, we're looking at the atomistic to the mesoscale. One of the examples, this is giving an example of that approach within Marmot. It has to do with fission gas release. And it goes from diffusion of fission gas atoms into bulk UO2, the resolution of intergranular bubbles, xenon segregation, clustering, and bubble nucleation, to bubble growth and coalescence, and finally to percolation and polycrystalline networks. Now, the graphics here kind of give a little bit of flavor of that. The atomistic simulations of diffusion, density functional theory, and molecular dynamics calculations have identified mechanisms and diffusivities for intrinsic and radiation-assisted fission gas diffusion. And then the fission gas resolution is treated by binary collision Monte Carlo simulations. And then the xenon segregation to the grain boundaries is dealt with molecular dynamics simulations. And more information, as you can see there. So this is just to give you an idea and put our scope into some kind of tangible context. So the work scope is here, where we would like to see requests that for innovative separate effects irradiation tests of nuclear fuels and or related materials that would provide data important to informing and validating mechanistic microstructure-based models of fuel behavior under development using Marmot, which is the Neams tool for simulating the microstructure evolution under radiation. So the Marmot models under active development, again, are we can address that through follow-up questions, or you can also see those under Neams 1.1 in the SINAR FOA work scope section. It's also available in the Marmot assessment report, which we can provide if you would like, and it may also be available on an INL website, but we'll help you with that. Fuel systems of interest in this area. Obviously, the light water reactor fuel system is of interest, both the historic UO2 fuel and zirconium-based cladding, as well as the emerging accident-tolerant fuel concepts. And the other area are the sodium fast reactor fuel system, uranium, zirconium, and uranium, plutonium, zirconium metallic fuel, and steel-based cladding. So this is the first time that we've addressed this subscope and made an attempt to integrate our efforts with the NSUF scope, and we're hoping that we can get some good proposals and fund these to to the advantage of Marmot and Fuels program. So that's all I have to cover for that scope. If there's any questions, be glad to answer them.
Did you define separate effects?
Well, we didn't define it in the scope. I think I've read several versions of separate effects, and I think that can be a dangerous swampland to get into to argue over what is separate effects and what isn't. Conceptually, if you a separate effects experiment is one that tends to give you information and data that's addresses a particular effect or physics, and it allows you to see that and analyze it in a way that it's isolated or separated from the other interactions that other contributions, so you can see what that particular aspect, how it affects your it gives you that data, which allows you to address that particular aspect in your code in terms of validating it. If you have combined effects, you can validate for those, but sometimes, especially when you're looking at the lower length scales, you want to be able to address one phenomena or one aspect of the physics, and so you need data that can help you do that. I am not the expert on separate effects experiments. I know, Brad, if you have had some experience in that area, or if we, is there, does that answer the question, or do you want us to, is there, I think we would entertain your, if a proposal came in and said, this is what we propose as separate effects, of course, we would evaluate that fairly, and there's no intent to mislead you here.
So the follow-up there is the PI asks, it's essentially an isolation of variables then.
So, yes.
The NSUF person here said parametric study. Where do you find the workbench-related report or document?
Brad, yeah, let's. Brad will address that.
Yeah, so Workbench is actually a brand new concept for Neams that we've just proposed in the last few months, beginning with a Neams Leadership Council meeting in January when we decided to undertake this initiative. So there's very little documentation available for it. Part of it is based on the user interface that's distributed with the scale code system, which has documentation in that context. If you need additional information on the Workbench and the concept of templating, it is deployed with the UNF standards tool, which comes out of the NE5 use field disposition program, as well as the scale code system, or just follow up with an email to me and I can get you some more information.
What is the relationship between Neams 1.1 and Neams 2? Are they interconnected?
They certainly can be. In Neams 1.1, your proposal would not involve use of the NSUF facilities. It would be probably, if you did some kind of experiment work under 1.1, it would be in another facility, a university facility or some other facility. The purpose of this scope is for those proposals that would want to use an NSUF facility, this is a path forward for doing that. And not only that, I believe in this scope, correct me if I'm wrong, Rory, but I think that this particular mission supporting scope, it's not restricted to universities. That is restricted to universities? Okay, all right. Okay, So it's a new area for us. But we needed to get into this area. We needed to give that flexibility to provide proposals that would make use of NSUF facilities. This was one area that appeared to be the most relevant. Yes, some of those proposals could overlap the work done in the others, but the difference is the NSUF component.
So there's a question that dovetails well into that. An individual asks, can universities lead in this work scope? And the answer is universities are the only institutions that can lead in this work scope.
But they can partner with industry partners and lab partners. Yes,
correct.
And that's encouraged.
Is a proposal expected to address all of the problems or just focus on one? For example, efficiency increase and mock solvers, V&V for series of reactor types, etc.
Could you say that question again?
Is a proposal expected to address all of the problems or just focus on one? For example, efficiency increase for a mock solver, V&V for a series of reactor types, parallel computing, etc.
First of all, is that directed towards the other Neams scopes?
It's not clear from the
that
question.
May be a question for the other Neams scopes, and I'd like to take time to answer that later with our reactor product line lead. I think that deserves a more thorough answer. In this scope, it's focused on Marmot.
The FOA says it is our responsibility to submit to the correct work scope. Since Neams 1.1 and Neams 2 are so closely related, will an exception be made for proposals which are submitted to one which might better fit the other? I can answer this one. The answer is no. And there's a very important reason for that other than what's stated in the FOA. Neams 2 requires an LOI to be submitted so that the NSUF staff can start on a feasibility review. So there's no opportunity, especially in these work scopes, to provide a shift regardless of the circumstances.
Let me address what I think is at the heart of that question. The motivation for it is that, if there's a fine distinction between two scopes, somebody might make a mistake. But what I'm pointing out here is that there definitely could be proposals that aside from the facility that they use, could fit in either scope. But the difference is that if it involves an NSUF facility, it must go to the Neams 2, to this NSUF scope, related scope. Yeah, and they can always check with us on that. We don't want anyone. We're not here to pull the rug out from anyone or to play the game with them. Check with us first. We'll answer that question.
A reminder is in this Neams 2 work scope, LOIs are due on August 29th. And that is an important date since if an LOI is not submitted, you cannot apply to this Neams 2 scope. As a clarification on the last question, there was a question for Neams 1.3, and it was referring specifically to M23, the code M23. So I'll repeat the question.
MC squared 3. Okay.
A proposal is expected to address all the problems or just focus on one. For example, efficiency increase for mock solver, V&V for a series of reactors types, parallel computing, etc.
I think that a lot of that depends on the nature of the proposal. Certainly a proposal that focuses on one or two of the problems is welcome. It could be, though, that the nature of solving one requires solution in other areas. I wouldn't want to predict. Brad, did you have anything to add on that? Okay. Yeah, I think it may be that you can you can separate them, and I see that possibility. Wouldn't want to say otherwise. So we'll entertain that.